Hello! Today we're going to be talking about how to calculate the price of a bond. But before we do that, I want to talk a little bit about how bonds work. You can think of bonds as a form of debt, in some ways similar to a loan that either the government or a corporation takes out in order to get cash for projects or programs. So let's say this company issues a 2-year bond. Instead of getting money from the bank, it's the public who loans money to the company. Whoever wants to buy a bond can do so, and that's usually done through some financial exchange market. The amount of money that the company receives up front for issuing the bonds is called the issue price and is represented here in orange as sale of bond. Now, bonds make interest payments, which are usually paid semi-annually, meaning twice a year. As you see here in blue, we have 4 different interest payments. One halfway between year 0 and year 1, one at year 1, between year 1 and year 2, and then finally at year 2, which is the end of the bond's life. Finally, there's a par value or principal payment at the end of the life of the bond, which we see here in green as principal payment. The amount is usually a little bit more or a little bit less than the selling price, which depends on the interest rates. So there are 4 steps to calculating the price of a bond, which I've tried to color code here with the picture to make it a little bit easier for you. First, you need to calculate the interest payment, which is made every half year. Then you need to calculate the present value of the principal or par value of the bond. Remember, this is the payment made at the end of the life of a bond at year 2 in my example. And what we mean when we say present value is that the same amount of money has a different value depending on the time someone owns it. So for example, let's say that I have $1 million today, maybe here at year 0. So that's better than $1 million in 2 years at the end over here. And I think everyone would rather have money today rather than waiting 2 years to have that same amount. But more specifically, we'd say that I could invest that $1 million today and make even more than $1 million in 2 years. So we say that $1 million has a different value depending on which time period it's in, because I would or wouldn't have the opportunity to invest it depending on which date we're talking about. So let's say that I have $1 million is not going to come to me until year 2. What we would do is we would have to calculate the present value of that to figure out the value of it at year 0. And really all that's saying is how much would I have to invest today in order for it to grow to $1 million in 2 years. So that's all we're doing here in step 2, calculating the present value of the par value. We have some par value that's going to be paid out here, so we say how much would we have to invest at year 0 in order for it to be at the amount of the par value in 2 years. Next, we need to calculate the present value of the interest payment annuity for the bond. Now the word annuity is just a fancy word for payment of a set amount that happens at set intervals. So in this case we have the interest payment, which happens at set periods, so every half year, and it's for one amount. The amount of the interest doesn't change, so we would call that an annuity. And just like with the principal payment, this is happening sometime in the future, right? It's not happening at year 0. It's happening all these different times. So we'll have to find the present value of each of these interest payments at year 0 for step 3. Finally, step 4 is just to calculate the selling price, and that's by adding up the numbers from step 2 and step 3. Sometimes you'll hear that the selling price of a bond is the present value of all future cash flows. Well, there are 2 types of future cash flows. One is the principal, which you calculated in step 2, and then the interest, which we calculated the present value to in step 3. So if we add these 2 present values together, we're going to get the price of the bond. Okay, so now we are ready to look at a problem. Alright, so the problem says, on January 1st, 2011, Chewy's Pet Grooming issued $500,000 of 10% 2-year bonds. The bonds were dated January 1st, 2011 and pay interest semi-annually on June 30th and December 31st. The market rate of interest on the date of issuance is 12%. We are asked to calculate the issue price on the bonds using the present value tables and to complete the journal entry for the issuance of the bonds. So I've set up our 4 steps here on the right, along with the calculations we're going to have to do, the formulas. So first we have to calculate the interest payment. So first we need the par value. We need to multiply that by the contract rate and then divide that by 2. Again, the 2 is coming from the semi-annual payments of interest, meaning twice a year. So first the par value, if we look over here, we see that the par value is $500,000. We issued $500,000 of 10% bonds. So this is $500,000. Now the contract rate is always listed right along with that par value. So that's going to be the 10%. And then we have to multiply those, divide it by 2, and that gives us an interest payment of $25,000. Next, we need to calculate the present value of the principal, which is the par value times some table value. So first, the par value is again, well, $500,000, just like it was last time. But now we need the table value. But first we need to determine the table inputs. So that's over here. And when we say table, we mean it's going to be some present value table, which I'll bring up in just a moment. So first we need the market rate of interest divided by 2. And if we look a little bit further down, we see that the market rate of interest is 12%. So we take 12%, divide that by 2, that's going to give us 6%. Now what they mean by market rate is they just mean other bonds that are similar, maybe issued by other companies that are of similar size, maybe in the same industry. They're issuing their bonds at about 12% rate of interest. Now the years just refers to, well, how long are these bonds going to be out? And in this case it was 2 years. They were 2-year bonds, so we take the years, 2 times 2 is going to be 4. Okay, this 4 might be looking familiar to you because if you look back at our little graphic we made over here, you can see that there are 4 interest payments. So when we took the years, 2 years, and multiplied by 2, that was really just calculating we had 4 interest payments. Okay, so now the next thing to do is to find the table value. Now there are 2 tables that you might be using here. One is the present value of $1, and the other is the present value of an annuity of $1. So you're going to use the present value of $1 anytime you have a one-time payment. So if we look back at our chart here, the principal, which is what we're trying to find the present value of right now, is a one-time payment, right? It only happens one time at the end of the bond's life, in year 2 in this case. So we're going to use the present value of $1. Now you'd use the present value of an annuity of $1 if you had a payment that happened multiple times, which in this case is going to be the interest. So that's how you know when to use each of those 2 tables. For the principal, you're going to use the present value of $1. For the interest, you're going to use the present value of an annuity of $1. So we can go over to that table, present value of $1. And we'll remember that the number of periods was the 4 we found. So we can highlight that row. And then the interest rate, we calculated that to be 6%. So we can see the intersection right here is 0.7921, 0.7921. So if we go back to our price tab, we can put in the table value of 0.7921. If we take the par value and multiply it by the table value, we get a present value of the principal of $396,050. Next we have step 3, which is to calculate the present value of the interest payment annuity of the bond. So we already know the interest payment. We found that up here is $25,000. We need to multiply that by the table value. And as I just noted, this is going to be the annuity since the payment happens many times. So we're going to use the present value of an annuity of $1. And again, we're going to use these same table inputs as before. So 6% and 4. So we're going to look for 6% and 4 periods. That gives us 3.4651. 3.4651. So 3.4651 is our table value. So we take our interest payment, we multiply that by the table value to get our present value of interest of $86,628. Alright, now we can do step 4, which is to calculate the selling price by adding the results from number 2 and number 3 together. So the present value of principal is $396,050. The present value of interest is $86,628, which gives us a selling price of $482,678. So note here, this is a little bit less than the par value of $500,000. So that's why we call this a discount. We have a discount on our bonds for the selling price. Now if this number was greater than $500,000, so say maybe $520,000 or something, then we would say this is a premium on the bonds. We're selling the bonds at a premium. And you can actually tell if it's a discount or premium before you've done any of this work. And the way you can do that is just a comparison between the contract rate, which was 10%, and the market rate, which is 12%. So the way I think about it is, well, other bonds or other companies are selling bonds for 12%, that's the market rate, but you're only selling them at an interest rate of 10%. So it's not really quite as good of a rate as the other competitors. So therefore, in order to get the public to buy your bond, you have to sell at a discount since your rate isn't so good. So that's what we're seeing here. And of course, it would be the opposite. If your rate was higher than 12%, then you would be seeing a premium here. Okay, so now what I want to do is I want to show you how all of these numbers show up on this chart that I made earlier, this picture. So I've made another picture over here, and we can see how some of the numbers come into play. So first we have the sale of the bond, which the company was getting $482,678 for. And this wouldn't necessarily be from one person, it would probably be from a number of different people who are purchasing these bonds. But this is an inflow of cash, so I have this without a parentheses. And the rest of the numbers here all have parentheses around them, meaning that they are cash payments for the company. So they're going to have interest payment 1, 2, 3, 4, and then also principal payment, the $500,000, at the end of the bond's life. Okay, we are ready for the journal entry. So let's scroll back over here, like this. So this is the journal entry for the issuance of the bonds. So for issuing the bonds, from the company's perspective, we know we're going to be getting cash equal to the selling price down here. So that's going to be a debit to cash for that amount. So debit cash for $482,678. Okay, the other thing we know we have is we know these were issued at a discount. If they're issued at a discount, we use an account called discount on bonds payable. If they were a premium, you would call it premium on bonds payable. And I'm going to leave the value blank for now, and we're going to come back to that in a minute. But next, I'm going to use an account called just bonds payable, which represents the principal amount we're going to pay back at the end of the bond's life. So kind of going back over here, that's the $500,000 we're going to pay back, which is also the par value. So we can put $500,000 here. And then finally, the discount on bonds payable is just the difference between these two numbers. And we notice we still need to make up some amount on the debit side, so it's going to have to be a debit. So we'll take $500,000 and subtract $482,678 to get a discount of $17,322. Now, of course, if you had a premium on bonds payable, it would still go right here, but instead of a debit, it would be a credit. And it would still be the difference between these two numbers.